Today we will introduce Delta AS series PLC control Delta drive. Delta drive means Delta servo drive and Delta inverter. We will control this drive via CANopen handy instruction. So here you can see we separate AS PLC into two portions. First one is AS300. For AS300, we have to purchase CANopen function card AS-FCOPM and install this function card in the slot 2. For AS200 and AS100, you can find here we have a built-in CANopen port. So you have to install ISP soft and go to the hardware configuration. Then we find the function card tool setting and select the CANopen function card. And here we select the Delta special drive. Okay, and you define the CANopen node ID. And here we use 1 meg bit per second as example. Okay, and this one is for AS200. So you can find here we have a built-in CANopen. And also you can select the control mode is Delta special drive, and you can select either Delta special drive with AS remote or Delta special drive with CANopen DX301. And again, for today's example, we use 1 megabit per second. Then we come to the servo drive and the VSD setting. So at this moment for Delta ASD A2, A3, B3-M type, we can support this handy instruction. And for VSD part, we have a C2000 and the MS300. So for the node ID for servo drive, it will start from 1 to 8. Means maximum we can control at servo drive, and VSD also maximum at VSD. So the node ID for VSD will start from 21 to 28, and you can find this CANopen address in 0936. Okay, and for the CANopen speed in VSD is in 0937. So you can see the default 0 means 1 megabit per second, and for the decoding 0940 we use the standard. And for the control 0020 and 0021 we use CANopen. So you can see here is 6, and for the operation command here is 3. Then let's go back to servo portion. So the node ID will use the parameter 300. Okay, so you can find here is the station number for 300, and the port rate over here. You can see for the CANopen port rate 4. So for 401 or 400 or 403 is all acceptable as long as the second digit is 4. That means the speed is 1 megabit per second. And then for the control mode, remember here we should set the servo drive in PR mode 01. Okay, 01. So this is the setting for VSD and the servo. Then we will go to handy. And then here's for the handy instruction. So first of all, we have to build the CANopen communication. So we have to use the CANopen communication initialization. And for device, we have mentioned, we have servo and the VSD. So servo will use the station number or node ID from 1 to 8, and VSD will occupy 21 to 28. And for this command, for the S means the number of server for initialization. So if we put the number at, that means it will initialize ID1 to ID8. But if we use a 2, that means it will only initialize ID1 and ID2. Means only 2 drive. And for example, if we use BFD 22, then means it will initialize 21 and 22. Then the coming one is for servo on and servo off. So again, first one is the node ID, and second one, if we servo, then 0 means servo off, 1 means servo on. And for VSD, 0 means stop, 1 means spin mode, and 2 means top mode. And then we have speed control. Speed control for servo, the first one, S1 again is for the node ID. Then second one, S2 means the target speed, and the unit is RPM. But for servo part, its unit is based on 0.1 RPM. So you can see the range is 60K and minus 60K. So the maximum speed is 6,000 RPM. Minimum is minus 6,000 RPM, means in the opposite direction. But for VSD, the unit is 1 RPM. Okay, then the final one we will introduce for the position control, and this one only valid for servo. So you can see here we have two commands, DDR-BIC and the DDR-BAC. This one means incremental movement or relative movement, and this one is absolute movement. So first one is send the node ID, so you only accept 1 to 8. And second one is the position. So position, we will use the servo unit. We normally will call it PUU. So this one will depends on the servo electronic gear ratio setting. And the third one is RPM. So same as we mentioned in the speed control. So the unit is 0.1 RPM. And again, you can check the electronic gear ratio of servo here. So that means 100K PUU. Then servo will rotate 1 turn. Okay, so then let's start with the ISP soap. Then we select AS PLC, and then we double click the COM manager. And because we connect to COM manager with we connect AS PLC with LAN cable. So here we select Ethernet. You can, if you don't know the IP, then we can do auto search. Okay, here go to tool and select the communication setting and find the Ethernet. And we can check the connection status of your PLC. So you can see this is the AS PLC and firmware version. After that, let's go to hardware config. So we double click hardware config. Okay, then we double click here, and let's move to the function card tool. So here we can use either auto detect and use a scan, or we can use a manual setting. So remember the card is for CANopen, so it's AS-FCOPM card. And here we will use Delta Special drive and the CANopen DS301. The difference of these two is this one can use only Delta remote I/O, but this one you can connect to the standard third-party device. Okay, and here we will change the ID to 127, or you can change to other value. Here we don't use 1 because as we mentioned in that the servo drive will occupy 1 to 8, so here we will not use 1. So we will set it out of 28. Okay, and then we can select the CANopen speed to 1 mega bit per second. After that, we download the setting. Okay, so when it's done, then we can go here and open the program, new POU. Here we still use a latest example because you don't know the command, so we can use the API and find the Delta special drive. Okay, so the first one is initial. So in our current architecture, we have two server drive. First one is R-star H3-M, and second one is R-star B3-M. So here we set 2. That means we just initialize 2 drive. Okay, then second one, we have to do the server on and server off. Okay, so server on means ASDR. So here is the first station, and if we put 1, that means server on, and if we put 0, that means server off. So here we will use the server off. And we can copy this to network. And then paste. Okay, then after that we can add the speed control. Speed control, we have to select this one. Okay, then we can add the relative movement or the so-called incremental movement. And here we can also define the speed with certain data register. Okay, so we use XX1 and we can define the position. So for example, okay, so after that we can download. Okay, sorry, one more. We can add on the servo parameter read write. So and we will read the servo feedback position. So the position is P5 16. We convert it to the index would be 2510. Okay, so when we finish, we download the program. Okay, then we can switch online. And first of all, build a connection. So this one to initialize. And of course, you can refer our user manual that you can use SM1681 to reset the signal. Okay, then we can do the servo arm of A6 and servo arm of second A6. Okay, then after that we can set the speed. And if you still remember, the unit is 0.1, so if we put 1000 here, then that means it will move 100 RPM. Okay, so then we can connect to Delta servo. And we can read the information of servo drive and servo motor. So you can see this is A3 400 watt servo drive, and we connect to 200 watt servo motor, and this is the serial number. Okay, we can read the parameter. So you can find the control mode here is 1, means PR mode, and the station is 1 for A2. Okay, so we go to scope. Okay, so here we can monitor the speed. Okay, so we check the real-time speed in channel 6. So we can see the value is roughly 100. Okay, and then we stop. Okay, so you can see here stop, and again then we will connect to P3 servo drive. And again we can read the information of what is servo drive and servo motor. And let's read the parameter and check. So here you can find the control mode is PR mode, and station is 2, and here is 403. And as I mentioned in the previous page, that as long as the second digit is 4 is okay. So the final digit doesn't matter. It can be 0 or 1 or 1, 1, 2, 3. Okay, and then we open the scope again. Then we run the servo. So you can find the channel 6 is for real time, and we will give the command here. And now we change it to 20K. So that means servo will run in 2000 RPM. Then we off, and let's go back to check. So you can see here is around 2000 RPM in channel 6, and then we stop, so it becomes 0. And again we change to incremental movement, and let's check the servo parameter in H3. So you can see here the electronic gear ratio. Let's go online and we can check from the electronic gear ratio over here. So you can see here is 100K pulse, then motor will rotate 1 turn. So here we will give the command 200K. We use the 500 RPM. Then we trigger enable this one increase relative movement. And we can check from scope again. So let's go back to scope. And here we check the feedback and command. So let's try again. We off and on. And we will do again off and on. Okay, then let's go here and we stop. So let's remove the relevant. So you can see from here to here. Command to feedback is 200K, and also 200K. Okay, so that is position control. And the final one, we will introduce the CANopen parameter rewrite, and maybe we go to parameter first. So That one we work with the feedback position of servo drum. So we can see this value is quite huge in 516. And if you don't know how to calculate, then you can just go offline first, then we press F1. So here we'll show you how to calculate the index. So for example, we will read the 516, so that means will be 2510. Okay, because it uses hex decimal. Okay, so let's go online and we will read the feedback position. Okay, and you already see the value is quite big, not consistent with this one. So we have to go to the device monitor table and check the V3000. So this is the value 219.74919. Okay, so we go here check again. Okay, so it's exactly the same value of okay, you can see these two values. Okay, so that's all for today, and if you apply this one for VSD, same rule. Okay, thank you.